Hello, hello everyone. So my name is Swapnil Sansari. I'm CEO and founder of Divide by Zero Technologies. There are a lot of things written here about me by my team. However, I've been instrumental and extremely passionate about 3D printing and robotics since last 15 years, and we we've got a lot of awards, recognition for the work that we have done. I'm also a guest lecturer at IIT Guwahati for product design and designing with 3D printing. Uh, I've been instrumental in gathering all the 3D printing community in India together, and driving the change. So we have an association called Indian Additive Manufacturing Forum, and I was a vice president there. And uh, due to some reasons, I'm still carrying the uh, position. We're also instrumental with Indian Machine Tools Manufacturer Association for helping them with 3D printing, and now uh, I'm also helping Government of India and METI and NCAM with a lot of ideas and possibilities of how we can grow 3D printing businesses in India, 3D printer market in India. Uh, so that's about me. But even though this looks this way, it just started with one idea uh, back home from my drawing room almost 12, 13 years back when I built my first 3D printer. This was for me. I used to come back home doing job, daytime job, and build this machine. And this was a hobby machine that I built for myself. And eventually, it kind of took off. And today we are here. We are one of the largest 3D printer manufacturers in India. We are one of the first companies to export 3D printers in India. Why I'm showing you this is today, with this session, we can, if we can generate some interest in you, this is something which is possible. People say building tech business, especially hardware business, is difficult in India, but no more. We are the live example here. This is possible, and we have been growing ever since. Right from one-person team starting business from house to now a 30 people team with such a large customer base. This has been our journey, and this is something which is possible for you as well. So with the spirit of transferring the knowledge that we have gathered for all these years, I'm beginning today's session. This was one video done by Flipkart about 3D printing an idea. This they shot, and we did a lot of 3D printing for them back in 2011-12. But somehow it didn't catch the speed, or maybe it didn't took off. The idea didn't took off. I just want to show you the video. It's kind of a commercial that they made with 3D printed um, you know uh, prototypes or toys, and we'll talk about what went wrong and where the gap is. But I just want to show you this video and what was the dream or the idea of 3D printing that we all saw when this technology began, and where this is going right now. Where are the business opportunities? I'm also going to talk about materials. I'm also going to talk about ROI, business plans. I'm also going to show you some tools uh, wherein you can find leads, businesses. You can also find a lot of solutions to your 3D printing problem, an option to get access to that tool as well. And beyond that, I think there are a lot of things that we want to show. So let me just quickly hurry and show you this video first.
बचपन में मैं हर रात दादी की रजाई में घुस जाती कहानी सुनने, और वो ना इतने जोश से वो कहानियां सुनाती कि वो जो कैरेक्टर्स है ना, वो आज तक मेरे दिमाग में दे स्टिल फ्रेश. गरुड, द ईगल मैन, वॉरियर ट्विंस, लव कुश, दे वर माय सुपर हीरोज. और जब भी टाइम मिलता मैं उनके स्केच बनाती, जस्ट द वे आई इमेजिन देम.
मुझे इंडियन माइथोलॉजी में इंटरेस्ट था और इसे मेरे टिफिन में. बस हो गई हमारी दोस्ती. अच्छा, एक दिन इसने मुझे अपना स्केचबुक दिखाया. आई वाज लाइक, वाओ, आई फेल्ट इनका कुछ तो करना चाहिए.
We started working on ideas after office and before office too, actually. खरोल बाग और वसंत विहार के बीच में यही टॉपिक चलता ऑल द टाइम।
Then it suddenly struck me कि क्यों ना हम इनके टॉयज बनाएं और छोटे बच्चों में अपनी माइथोलॉजी के लिए इंटरेस्ट जगाएं। सी मेरा बेटा फ्लिपकार्ट पे एक टॉय के लिए जिद कर रहा था, उधर से ये आइडिया आया हम भी फ्लिपकार्ट पे ही सेल करते।
लोगों को ना अकेले अकेले बड़े आइडियाज आते हैं और चले भी जाते हैं, पर एक पार्टनर मिल जाता है ना तो एक हिम्मत आ जाती है। फर्स्ट मंथ वी गॉट एग्जैक्टली 182 ऑर्डर्स।
जब हम दादियां बनेंगे तो कहानियां तो हम भी सुनाएंगे, बट आई टेल यू व्हाट, एक कहानी सबसे ज्यादा एंथू से सुनाएंगे और वो होगी हमारी।
अपने सपनों को जी कर देखो।
So, this was the ad. No more, Flipkart is not paying me for promoting them here, or nothing's happening of that sort. However, this was the idea that they had and everybody had when 3D printing started. And there is something called as hype curve. When any technology comes, people say, okay, this is going to change this, change that, and all that happens, and a lot of people try and invest. And then it kind of, people realize that, okay, it's not useful here. It's called hype curve. You can search in Google for it. And then slowly people understand, or okay, where this can be applied, and again it normalizes. So that hype curve is gone now. Back in 2014, 15, 16, it was on hype, but now 3D printing has been utilized and used and applied in real areas, real applications. So we will be looking into that part now. And also now this dream is possible. Back then there were a lot of issues, material limitations, there were issues with fragile components being printed, color limitations, and post-processing issues, and so on and so forth. But we are going to not only look at something like a toy, but also end-use real engineering applications. So you all know what is 3D printing. I'm not going to go there. If you still want to know, you can quickly go to YouTube or Google and check that out. But however, 3D printing is a layer by layer process where you can add layers according to your part geometry, one layer at a time, and it can actually build a component. So typically in manufacturing, you have three methods. One is your, additive manufacturing, or 3D printing as we call it. Subtractive, wherein you have a, say, maybe block of wood or metal, you machine it down and make your shape. So this is the component that you want to make. And third is your formative manufacturing, which is also known as injection molding or molding, wherein you have a mold and then you pour in a material and form the shape. In all these three manufacturing methods, one thing which is very I would say common is that I think it's visible now. So if you look at this graph, this is about cost per part versus quantity. So if you want to make, say, if you want to make, say, maybe a component with formative or injection molding beyond, say, maybe 1,000 or a few thousand components, maybe this number is wrong here, this should be 1 lakh or so. So, after that, the cost starts reducing because your initial cost is very, very high for the mold or for the tooling. Parallelly, when you look at subtractive or CNC machining also, for 1, 2 of parts, again, your tooling cost is high, right? But with 3D printing, even if it's 1 component, 10 component, or 100 components, the cost remains the same. It doesn't change much. Now, what happens is between, say, maybe 0 or 1 to few hundred components, 3D printing still has advantage over CNC machining and injection molding, especially when components are complex and they have undercuts. Okay, I definitely, I think many of you might have your own set of questions here in terms of how it works and how this is feasible. So that part is very important. So typical AM process is your pre-processing, 3D printing, and post-processing. You all know this. And however, there are different technologies. You have metal 3D printing, you have SLS, you have FPM, you have AFPM is one of our technologies that we have developed, which is similar to FFF, but it's an add-on. And the cost ranges right from, say, maybe 50,000, 20,000 rupees, 15,000 rupees to, I think, few crore rupees, and beyond that. There is this whole gamut of concrete 3D printing, tissue 3D printing, metal 3D printing, resin, or maybe plastics, polymers. Okay, and typically we're going to talk about polymer 3D printing right now. So in this journey, why this is the right time to switch to 3D printing is because right now a lot of us are post-COVID, in the post-COVID world, we are facing this change of Industry 4.2 and additive manufacturing coming together, and everybody saw challenges in terms of what goes wrong if there is a supply chain disruption, and everybody understands it, and that has kind of changed the game. uh, there are a lot of things that have changed, supply chains, or maybe your assembly lines have changed, there are robotic lines, but there are a lot of areas in industry they are still the same. Your investment casting process, mold making, pattern making process are still the same. That needs to change. If that can be changed and that can be accelerated, or change can be brought there is a huge gap in terms of business that you and me can actually handle. As I said, in additive manufacturing there is tremendous growth right now. Especially it has moved from prototyping to application specific 3D printing. So earlier it used to be that okay, they just want a sample. Now they want prototypes, they want end use components, they want tools, and fixtures, molds. Many applications are there. I'm going to go a little faster. If you have any questions, please park these questions in the chat so that I can take this in the end one by one. And small and complex parts, expensive parts especially, if you have to ship them across continents, 3D printing is much easier an option. A company, maybe a German company, car manufacturer, if they have any old component which is to be replaced in India, instead of shipping it out, they can directly send a digital file to one of the 3D printing service bureaus in India. If it's a metal component, they can 3D print it, get it finished, and get it delivered to the metal or polymer. Either way, it is possible. And right now, like we've seen first revolution with water and steam, it was complete replacement with new tools. Second was like tooling and equipment kept, was only kept, only conveyor belt was there, so it kind of was continuous manufacturing. Third was electronics, automation, robotics. And now fourth industrial revolution is about digital manufacturing. And here everybody is looking at upgrading their equipment and kind of pushing the limits. But what is happening in this area is that right now we have AI, we have tools like ChatGPT, Claude, and so many, Google Gemini, and all those sort of tools coming in together. In the IoT is already there, data analytics is there, robotics and 3D printing is there. So with all of this together, the transformation of $12 trillion manufacturing market is happening. And right now, innovation is happening at very high speed. People want products in the market in very short time. So the new products keep on coming every month instead of it used to come every year. Companies want to keep less inventory, so they want to have inventory light models, and that's where 3D printing is game changer, because whatever is required, we call it just in time manufacturing earlier, but now it's like with 3D printing you can run inventory less models, better and more efficient supply chains. What if you do not have to ship a component from one place to another, and rather you can just send a design file in 3D print? I can have a head office in Delhi and I can 3D print this in China or Chennai or Hyderabad or Delhi, anywhere, and very high capital efficiency, because with typical generic capital investments, the efficiency was very low, and with change of designs and tools, and especially when it comes to molds and tooling, uh, the efficiency was something at risk, because you never know when the next change is coming in, and market might need that change. But if you cannot provide that, the whole company, top line and bottom line can take hit. So earlier additive manufacturing, traditional manufacturing method was you need a design, you were looking at prototyping and then tooling for prototyping, and then have a small hand mold or maybe vertical mold, get that component made there. Again, you have tooling, then go to production, then logistics, supply chain, and then product is delivered after so many processes. But with additive manufacturing, what is possible is you can design it, print it, and deliver it. Yes, there will be prototyping processes, but that can also be handled through the same method. And this is the beauty of the whole process. Right now, in terms of additive manufacturing, there is huge gap when we talk about, what's happening is manufacturing, which was offshore, is becoming local. Logistics was global. They are just last mile. That means I instead of delivering a component from, as I said, Germany to Chennai, I would just have a hub in Chennai where company has their own print farm, and then from there they can deliver it to the local customer. New product development was slow, and that is becoming extremely fast now. Production cost has come down, especially when it comes to customized components. 3D printing still cannot compete with molding when it comes to high volume, mass manufacturing for sure. Inventory has gone from physical to digital. I'll explain some of the examples now. And demand planning is, which was unpredictable earlier, is completely predictable because you are actually manufacturing whatever is required, as much as required, and within timeline. So this is a complete game changer right now. So which are the industries which are adopting additive manufacturing in the larger way, in big way right now, especially in India, from where I see. So military and defense is one area which is going big way in terms of 3D printing, utilizing a lot of, they're trying a lot of options for 3D printing and post processing. In fact, having machines that can, or maybe even prototypes that can actually withstand the military grade specifications, and that is possible now. They're also open to work with a lot of companies to develop this. Aerospace engineering, yes, big way. Mobility and transportation, automobile industry has been a game changer. In fact, that's the industry that has gotten or accelerated 3D printing adoption in big waves. Healthcare, yes. Orthotics, prosthetics, and even surgery planning. I'll show you some examples. Consumer goods and electronics, yes, this industry is also moving towards personalization. A lot of changes are coming. Industrial services, when I say industrial and services, maintenance, companies that are doing maintenance or doing a lot of products which are obsolete, and they are still providing support for that. Big gap here. Agriculture, mining, and energy. These are three sectors. In fact, I know a lot of companies in India providing and supporting, companies in UAE and US and Germany and Europe, most of the regions for mining, energy, and agriculture components as well. A lot of automation is happening in this area. Drone is one more like area which can be looked into. So when you say typical prototyping, yes, again, you can look at standard options. Many of you already know this. So from design to physical component, industrial applications in terms of possibilities. So these are special applications, and whenever somebody asks me, Swapnil, where do I invest, or what is the area where I should, look into, there are so many options. I would say, first of all, look at where you are in terms of geography. What are the industries near you? Who are your contacts? And what is the skill set that you have? Based on this, you can always, look into what area you want to choose, and that should be the area where you can get maximum impact. However, in the end, we are also offering you a one-on-one session where we'll discuss this. We'll give you a machine demo and also discuss more. So that can be your case specific as well. So jig fixture is one area where you need to, you can develop 3D printed fixtures now. There are tools. We have also coming up with a company or a tool which can help you build a fixture without any CAD software within 15-20 minutes for any complex job. So this this is one big area, jig fixture, huge cost saving with 3D printing up to 80-90% here. End of arm tooling, grippers. So robot grippers are something in big way, that's happening. There is a process called inlay molding, wherein a lot of labels are inlaid in the mold itself, and for that also they need specific grippers which can be 3D printed. We are doing that. Soft jaws, custom work holdings, because with 3D printing machines you can actually build parts with polyurethane or polyethylene, and that can be actually used here. Welding fixtures. I have one welding fixture here. I don't know if it's visible. Let me see. I might have to stop. sharing my video. Let's see. Okay, can you see me? Yeah, I think you can. So this is a one welding fixture. Okay, some video setting here. Okay, this is one welding fixture wherein the component, is this, and they put in metal plates here, different metal plates here. I've removed those plates because they'll fall off. Okay, and what they can do is, this is 3D printed fixture, but you can only have, kind of these supports 3D printed and have a flat metal or any other composite plates here that can work. A lot of such fixtures in bulk. So this is something which we have built as an example, but in cases where we have provided a lot of such fixtures to our customers, this kind of goes because we cannot show those examples here because of the NDA that we signed. However, this is an option. Go no go gauges, inspection fixtures, forming tools. So I'll show you some examples: digital inventory and tooling. So when you say end of arm tooling, robots and a lot of grippers and areas. So if you know this area and if you understand this very well, lot of components for every robot implementation, for every organization when they put in, even if it's a vehicle. Suppose if I'm putting up a robot for say one particular brand and type of vehicle, if the vehicle model design changes, the grippers and end of arm tooling will change. So based on that, then continuously need such tooling. This is one area that you should look for, you can look for. Jig fixtures in big way, because assembly fixtures are required for all sorts of automobile or consumer appliance companies, and they are required in bulk. However, each fixture is required in one or two quantities only. Now, if you want to do this on a CNC machine or molding, it's not possible. It's going to be super expensive. However, with 3D printing, or when they compare it with aluminum fixtures or any other fixtures, okay. Okay, so with all sorts of such fixtures, they can save a lot of money. More than 80 to 90% saving is there. Only trouble here is how to design these fixtures, but for that as well, we are coming up with a software solution now. So you be in touch with us. We will be sharing that news with you. Huge advantage here. Sheet metal press brake tooling. This is again a tooling which can be done for trial and maybe 100 or 200 runs, up to 1.5 mm of mild steel, aluminium, 1.5 mm of aluminium, 1 mm of mild steel, and 0.8 stainless steel 316L. This can be used. This is good for small runs. Do not try building this tool on your normal 3D printer. This tool might break and it can cause an accident. So because this was done with a lot of care, calculation in terms of tonnage, and this was developed in a polycarbonate material. If you have any questions, I'm going to go a little faster. So wherever you have questions, please park those so that I'll try and address. And even beyond that, if you have more questions, you can connect with me. We will share a link with you in the later stage. Pulp packaging and fiber packaging solutions. Big way you can make these molds and maybe even make sample fiber packaging options, because when it comes to product designing, a lot of prototypes are available for the product, but for packaging prototyping, companies do not provide sampling, especially when you talk about fiber packaging and green packaging options. And this is a huge gap. You can actually cater to this gap and develop a specialized services here. Lot of you can approach all product design studios and tell them that you're doing this. This is going to be game changer. See, one common thread here is, do not provide print service per cubic centimeter rate. Add more value to your 3D printing and a design or your expertise, and sell that as something which has more value together, and that will be game changer for you. And this is where you will excel. Don't just do print services per cubic centimeter rate, because that is going to be a Xerox machine kind of scenario, wherein say maybe today you're doing it for say 10 rupees or 15 rupees per cubic centimeter. Tomorrow somebody would come there, would sell it at 9 or 14, and that would not be I think you don't want to be there in that zone. Rather, you have one expertise layer. Also, you can build vacuum forming tools on 3D printer. PCPBT material can be printed for high temperature vacuum forming molds. As I said, pulp packaging molds can be done. Casting patterns, huge saving. We have done patterns right from very small investment casting patterns to patterns up to 1.5 meter tall. Prototyping, yes, this is something that we did for Tata Tiago long back, and this is printed in 5 to 6 parts with dovetail joints. This was connected together. Art and architecture. How many of you are from art and architecture area? Again, if you're there, I have one more case study I can show you. If not, then I'll just skip. But huge business. Unless and until you already know this area, unless and until you have connects in this area, do not get into this, because this also needs getting in 3D files, converting them for 3D printing. We'll talk about that. Again, different areas. AM, healthcare industry, you can do surgical models, educational models, medical devices, tissue engineering, a lot of them together. And this is possible. Okay, healthcare industry, big way you can do changes, prosthetics, and orthotics, a lot of different options. Okay. So we spoke about aerospace, military and defense, mobility, transportation, healthcare, consumer appliance, industrial services, agriculture, and mining. However, healthcare tech is going to take lead for sure. Mobility in terms of tooling, especially tooling for automotive industry, is going to be something that you should be part of, because that's going to grow with 3D printing. Learning, education, if you could create kits that can help students to learn certain topics better, that can be work as educational aid. It can be for medical industry, it can be for engineering, it can be for physics, it can be for, and then that can be given as programs to students, because now almost all sorts of colleges or institutes are running 3D printing programs. And e-commerce is changing customer behavior. You can go to websites like Etsy and Amazon and search for 3D printed products, and you can still see a lot of components and a lot of products being sold there, which can be made in few bucks, but they're selling it in few $1,000s. So that is again a big market now, which is growing. AM and EV and UAV is going to grow. Right now, EV industry is utilizing this for fixturing again, especially automotive. We have a lot of customers in EV industry. Drone industry, a lot of small parts, especially look at custom companies that are building custom drones, agri-tech drones. Agri-tech drones are growing because they can solve the problem of fertilization, and all other areas automatically. And each drone is custom built, so that's where there is a big opportunity. Automotive components, I have one here in my hand, if I can show you. Yeah, I don't know if this is visible, but yeah, this is something which is kind of 3D printed and built. They need it constantly, and it's possible. But what went wrong with 3D printing, or what goes wrong usually? Typically, I think many of you must have witnessed this: strength issues, part cracking issues. A lot of times material absorbs moisture. You have temperature resistance issues. Customer says, I want component that can withstand engine temperature. Sometimes in fixtures, they say we need ESD static, ESD safe material, or elasticity, or flexible material, something like this. And abrasion resistance or cost is an issue. Okay. So what can be done? And for this, again, as I'm saying, post this session, we are sharing link with you, and we'll ask you to sign up. If you want, we can set up a machine demo and also discuss your particular problem or issue. I cannot address or tell you everything in detail here, but we can get in touch. So we also discussed about or we mentioned that we'll talk about material and how material selection can be done. Typical strength issues or part cracking issues, you can look at material like polycarbonate or PSCF or PETGCF. So if you want something which is cost effective, you should go for PETCF, not PETGCF. PETGCF has lower temperature, I would say glass transition temperature. PETCF is a little better, but either works really well. PACF, which is nylon and carbon fiber composite, or best, I think, is going to be polycarbonate. Basic material that you use has 41 MPa kind of tensile strength, ASTM 368 D638 method. Best would be PC, which you can look at. PACF and PETGCF. In terms of chemical resistance and weathering effect, many times a lot of you all come to us and say, okay, we want components that can withstand weathering, UV, or even sunlight. So you can use ASA or PP. PP is a little expensive, but ASA is again can be used, which is similar to ABS but has a lot of advantages, and that can be 3D printed. Temperature resistance, a lot of companies come to us and say, okay, we have never seen a material that is affordable and which has good temperature resistance. I would recommend you can use a material called PCPBT, which is available, which has good temperature resistance. Even though it says 160 on the specification, we have also tested this up to 175 degrees. And basic material like ABS can give you up to 95, they say on record, but I think it starts softening beyond 88 to 90 degrees. And again, you can look at nylon also as an option, nylon 6. But the problem with nylon 6 is it is super expensive, even from FFF machine point of view. When it comes to abrasion resistance, you can look at TPU or TPE, or again, PP, nylon 11 is also an option. Flexibility, elongation, again, PP, TPU, nylon. ESD-SEF, these are 3 materials, nylon, TPU, PC. All this information is there in our material selection guide again. And when you want to look at a material, a hero material that has advantages over strength, flexibility, weathering, cost, affordability, I would say you should look at carbon fiber based PET composite. Amazing material. This is something that you should be shifting onto. And this is where you can also do a lot of components that can be developed into end-use application. And all the information about how to use the parameters is there in our material selection guide that we will be providing you. You can build fixtures with this, a lot of different fixtures we have done. PP again is possible. It can be 3D printed, little difficult to initially set up the parameters, but once it is set, it can run very well. But this material again is a game changer. Nylon 6 is there, polyurethane is there. Again, with TPU, we've done a lot of these sort of another case study wherein small batch manufacturing, wherein this gym equipment manufacturer got order of around 50 to 100 units per quarter, and to get this polyurethane components molded for hardly 50 to 100 units was super difficult for them. We could actually 3D print, help them out, and they could build this in almost 1/10 of cost, because mold cost was really high for them, and their customer was not committing quantities to them. Now, something like this, you can do end-use applications, that is possible. However, when you do end-use applications, what you need is right material selection and right parameter selection, and that is where we come into picture. We help you out. Again, we spoke about polycarbonate, we spoke about the packaging tooling, and again, you can also do sand core boxes. If anybody wants to understand, park questions, I'll ask or maybe help you answer this. So we have developed certain machines that we have, wherein we have high flow hot all metal hot ends, which can withstand temperature up to 450. Hardened nozzles, bed can go up to 450 degrees. Liquid cooled heads, closed chambers. We have active filler dry systems, and most importantly, we have servo controlled extruders with filament sensors. But what is it? I have shown you so many things, options. Where are the real examples? Who is doing this? A lot of times people come to me and say, okay, Swapnil, बहुत सारी बातें तो कर ली, but कहाँ पे है, कौन बेच रहा है, हमको दिखाओ. So let me just show you some examples. Okay. Now this company called Zellerfeld here is doing wonders. They are now, they were on the cover page of Time magazine. Okay. They're using FDM 3D printers to build custom shoes. They have definitely customized their machines. I know the team, and I've seen them, observed them from distance since so many years now. So what you can do is you can secure your slot, and then you can initially pay some money and then secure. You can scan your feet using their software on phone, and then you can actually get a 3D printed shoe. This is FDM 3D printed shoe. Okay, you can see. We can definitely discuss about this in the on one-on-one. However, this is where you have different models, you can see, and they are making waves. This is shoe industry is $1 billion industry now, and they have non-stop new designs coming in. Imagine a shoe which is made to fit your requirements, your feet, or maybe I would say made to hug your feet based on your requirement. Can you see the pricing here? $380, $229, $159. TPE material maybe, or TPU material here. Almost 10, 15 times, 20 times margin. Definitely they have put in a lot of effort to build this and design and a lot of software, but this is where it is moving to. Now, second example I have is a company called Slant 3D. They have put in thousands of 3D printers, and they say we do mass production without the molds. And they claim that they are one of the largest print farms in the United States. Okay, these guys have, they're developed everything. So right from small requirement to large requirements, print on demand. They have created an API that can be integrated to any of the softwares, and these are their customers. This is this company which actually gets all the components 3D printed, and they have developed 3D printed robots that can compete with industrial robots with the accuracy, repeatability, and they have given all the test results. You can go to this website and check, right? So this was one area. Now, when you look at all of this, this looks nice. I want to build fixtures. I want to do this. I want to do that. From where would I get, designers? And a lot of people ask this to me. So you can go to this website. I'm going to share the link. This is called Upwork. You can easily search and hire 3D designers in India. These are the questions people have usually, where would I find? You have the rating here, what kind of jobs they have done, what kind of software. So you don't want somebody who's doing jewelry. You want, landscape designers, or what kind of designers you want. You can CAD CAM software. So this is the guy maybe I might want to go to. This is a guy who understands 3D printing, 3D design. I might want to go to. He's 5-star rated. So, you can easily find these people, sign NDA with them. Upwork kind of takes care of the deal wherein, they ensure the work is delivered and then only the money is transferred. So this is one option. Again, not sponsored. Upwork doesn't pay me here. However, this is just something that I'm doing. I'm sharing the link here with everyone in the meeting. Can check this out. Okay. Okay. Just a second. So I showed you Zellerfeld, I showed you Farm 3D, Greeny Plus is their Folds design. Anybody from architecture or would want to understand any case studies from this area? Again, this is mind blowing, and this can be a game changer for you. Do you want to know more, or should I skip and I just continue on the other part of the presentation? Okay, I'm just continuing to the other part of presentation now. So if you want to, look at your, as I said, AM journey, if you want to scale up, you can look at demography or industrial network where you are, what's close to you, because people would want to give orders to a vendor who is nearby and who has, set up nearby. Write applications, deep dive application vertical in that. Whatever support you need there, maybe you can get in touch with us. We can help you out. Appropriate technology and materials, so you should be looking into that. Sometimes just 3D printing might not help. 3D printing and then maybe post-processing with a CNC mill or, some other layer coating or something like that can be developed. And as I said, software and post-processing infrastructure. So a lot of times you also need certain softwares in order to run certain case studies or run certain applications. And then what is it that is another area that is required is design for additive manufacturing. Power cost, funding, setup and required space, other costs, hidden costs. But where is this going? There was one time when there were print servers, cloud servers, and with those servers, the whole, it took a revolution, and now you don't own server, maybe a data, center in India or maybe in any other country is holding up data that you and me, and even this call is routed through one of those, right? Recorded on some server in India or somewhere, but I don't even know where it is recorded. Similarly, now printer farms, 3D printer farms are kind of building up. Slant 3D has already done it. It has kind of given access or API to other websites wherein they can actually take in orders. So there is a company in Delhi that we are working with. They are a interior design firm. Now they have set up a website, and they can call in for a particular lamp design, lampshade design, or maybe a desktop or desk accessory in different colors and sizes. Whatever the order is placed from their central server in Delhi, the order is sent out to the last mile location. It can be in Mumbai or Chennai or anywhere, and then from there is 3D printed and delivered, along with connecting everything to, say, maybe FedEx server, and then FedEx guy knows when to come and what to receive, and package labeling and everything is automated. So this is possible. This is where it is all going. If you want, I'll just show you quickly. If you go to Etsy and say, see, this is what they're selling here already. And you can also download these designs. So they're selling designs as well. And this is in India. Okay, but this is more into art side again. But if you are looking at that kind of application, this is something which you should look at. Fine. Okay. So coming back to the final area, we want to invite you all for 1 30-minute one-on-one meeting with our experts and 3D printer machine demo. Once you are here, what we will be providing you with is an ebook wherein you can get material selection guide, complete checklist for your 3D printing setup. So what you should do, it's going to be independent of the machines that we have, the features we have. We want to give you a complete value here in terms of, if you want to set up a 3D printing company, or even if you want to scale it up, what is it that you should look for? So that has all the lists, including material, including, say, maybe you need dry area, you might need to have a special compartment for putting in the material, or maybe post processing, what tools you will need, what options you should look at, right? Everything. We'll also help you with the ROI analysis for your case, right? And maybe access to our new AI GPT, wherein you can do troubleshooting. I'll show you the demo now, which we have developed at Divide by Zero, and free sample up to 50 cubic centimeters. So you can actually check the finish and quality. We are very proud of what we have built here at Divide by Zero. So we can give you the sample and also give you a 3D file, and we can challenge you that you can actually give this sample out to any of our competitors and check the finish. If that doesn't match up, we won't bother you again, but we would definitely learn from it. But we know and we are very sure of this. So this is something which is possible. I'm going to quickly show you the tool. So this is called as 3D Print Fix Pro. This is something that we have developed recently. You can go here and ask any of the questions. Maybe one of the questions I got was, say, maybe my 3D printer. So it's going to tell you everything. You should do this, even if it doesn't work. Okay, so it is given, what all things you should do. You should optimize the temperature, enclosure environment, adjust print speeds, okay, adhesion, dry your filament, because polycarbonate is hygroscopic, it can absorb moisture, layer cooling is required, first layer settings, advanced tips. And this is based on, this model has been trained on our knowledge since last 12 years, and you can actually use this, okay? So I still say this is not helping. It has given me further, you can do this, turn the fan off, dry at 80 degree for 4 to 6 hours, and systematic troubleshooting methods. What do you think about this? Isn't it mind-blowing? And this is going to be yours for free of cost. We only want you to experience the demo of the machine. No questions asked. We are not going to push you to buy machines or anything. We just want to show what we are doing, and maybe get on call with you one-on-one. Also, a lot of you asked before this call that if I want to generate leads and we need help with marketing, how can we do that? There is a tool here which I'm sharing again, but there are more tools like this, and maybe we can give you a guideline This is called as D7 Lead Finder. So maybe I can go to, say, I'm looking at architects, okay, in Pune, and I say get leads. I hope I'm adding value. I hope this is helping you. This is going to take some time, 3 minutes, 37 seconds. So in the meanwhile, we'll take questions. I will let you, unmute yourself one by one. I'll answer your questions, and then maybe we can have one-on-one questions then. Okay. Just a second. Okay. So, yes, recording will be available, Srinath. Srinath will get in touch with you. Okay. And okay, do you have any questions in the meanwhile? You can unmute yourself and can talk. By the time we are generating these leads, this tool is finding leads for us in Pune region, architects in Pune.
Hello, can I ask one
Yes,
question?
yes, Anilji. Yes, you can ask.
Okay, so actually the question is different. We are actually having one printer, okay,
Mm-hmm.
and we purchased it around July, and it worked fine. We are doing 3D printing services business, okay. And what happened was in September the printer broke down, okay, and
Okay.
we faced some challenges in solving the issue. And so is it so firstly the question is whether and actually it took around 2 to 3 weeks for us to again start the for the company to start the work, okay. Now firstly, is it something that frequently happens, because that is what they tried to tell us, and they are telling us to have another printer in case, because right now since so for 3 weeks we could not do business, we could not deliver uh, the promises. So I want to understand whether this is a normal use case, or what are the things that do you recommend when certain things happen.
Right. So first of all, if the breakdown, was it related to the extruder system or it was something else?
Okay, so they told me some issue happened in the extruder, and they told me to replace the assembly, entire assembly, and then procurement happened. It took 3 weeks or something. It is a foreign brand. Uh,
Okay.
yeah.
So typically, yes, this is the case. It happens with a lot of foreign brands, especially when you have imported machines, because the even though they are selling, their complete machines are available in stock, but most of the times spares and consumables are not available. Also, you don't need to have a second machine. Rather, you can especially with their cases, there are no assemblies. I mean, they try and sell you the complete assembly rather than just the nozzle or the particular component that is broken or maybe damaged. Also, in terms of, just check whenever you're looking at buying any 3D printer, in our case also, or any printer that you choose, if the local service support person is available and the company has stock, because it is very important when you're running a business. You cannot say or tell your customer, hey, like our order, my machine is down and I cannot, deliver now. I need 15 days. You will lose the order and you might lose the customer. So it's always advisable to work with companies who have local presence and who can guarantee you, the service support and if the person is available. So yeah, I hope I've answered your question. Okay.
Correct. Yeah. Okay.
So this list is populated now. You can see all the names. You can print or export in Excel or CSV, PDF, and then get in touch with them. You have got phone numbers and all. Initially, they give you certain free numbers and then they charge, but at least you can try. There are more tools like these which we can share with you. To if you want to look at expanding business and getting in touch with these kind of people, and what you can, or how you can change about this is possible. Any other questions do we have?
Yes, yeah, I have, sir.
Yes.
My name is Omkar. I'm working in a small engineering company which is located in Pune. So my company is having the requirement of mid-size machine. So I saw your machine. The cost of the machine is 5 to 6 lakhs,
Okay.
and
Yeah.
that cost is too high for us. So how it is profitable for us, sir?
Okay. So Omkar, what is, I'll just show you the ROI. Maybe we can calculate this ROI for you. Say maybe you're looking at icon machine, around 5 to 6 lakhs. When you say we'll consider this 5,50,000 rupees value, what would be your monthly volume that you require, or requirement you have for printing, 3D printing, in terms of
Uh,
gram, kg, whatever, if you can tell me.
it's around 5 to 8 kg, I can say that.
5 to 8 kg. That's a lot of requirement that you have. Okay. Okay. So when you look at, just a second. Hmm. So when we are looking at this kind of 5 to 6 kg requirement you have, typical 3D printer can do up to say maybe 30 cubic centimeter an hour. This sort of machine, daily volume could be around 600 cubic centimeter, and for 25 days you can do up to 15 kg. So this is going to take care of your requirement in 15 days. And if at all you're outsourcing this, right now, where you are, you outsourcing this?
Yes, yes, we are.
What would be your cost? 10 rupees?
Yes, yes.
So if you are looking at say 10 rupees with say PETG CF or kind of material also, your whole ROI period is going to be 5 months. You need to look at this calculation. We need to, maybe we can share this on the demo. If you're up for a machine demo, we can also share this with you. And we have also built a ROI tool. See, savings after your ROI period, it's going to be, and we are considering 25 days working period. Okay, not even like kind of like full 30 days. You can also reduce this. So maybe I'll show you. You can also say maybe instead of 25 days, even if I make it 20 days working, it is still 12 kg, right? So 12 kg is also still double. Even if with that kind of calculation, your ROI period is going to be 6.4 months, hardly 7 months. And after that, your saving is going to be 8,58,000. Sorry, 85,800 rupees. And your saving after ROI period. So even if you are outsourcing this is going to be huge saving for you. Okay, the advantage with this machine is that it can deliver consistently and it can work for 20 days non-stop, because we have machines which have liquid cooled heads, we have machines which are completely enclosed and they are built like tank, and that's why I'm asking you to come and have a look at the demo. We have machines which have servo extruders, so they do not clog, because the clogging is the biggest issue that I think one of Sunilji also asked right now. Okay, so we can share, yes, Sunilji, we can share contact number of the customer that who's using our machines from Pune, and maybe you can kind of get in touch with them. And if you are there and in any region you want our customer references, we can give you that as well. But this is possible, and this you should do this study and also understand why this is possible. When you're looking at the machine, can it run continuously for 20-30 days is something very important. Most of the people, most of the companies do not give the specifications in terms of how many days or hours this can run continuously, and this is a game changer for sure. And yeah, I hope I've answered your question. So your ROI time is 6.4 months, and after that 71% saving on your 3D printing requirement. I'll share this with you over mail.
Sure, sure, sure. Thank you so much, sir.
Thank you. Okay, any other questions we have? Okay, thank you everyone for your time. If you have more questions, get in touch with our team. If you want to set up this demo, we will kind of get in touch. We can set up that demo, give you that sampling, and also help you with a lot of options and ideas that we have. The whole idea is to accelerate innovation with 3D printing, and we are here to support you in this journey, not only with 3D printers but complete applications and your end results and your bottom line and top line both. Thank you for your time, everyone.